Okay, ran out of time on that last video. So now we're going to look at 6 things being attached to a central atom. And the basic shape is this guy. So you could memorize every shape, just like the trigonopyramidal. You can memorize every shape, or memorize the base shape. When six things repel, it makes this octahedron thing. So it's a square, right? Can you see it here? I'll hold it like this. You can see the square, right? Square. That way, and if I hold it like this, you can see there's that pyramid on the top, pyramid on the bottom. This is a 4-faced pyramid on the top and a 4-faced pyramid on the bottom. 8 faces. This is octahedral. There's only 6 things attached, but it's octahedral because there's 8 faces. So if you memorize this and then think, what would it look like if I didn't have an atom here? Well, it would look like a pyramid with a square base, right? Because there's the square base and there's the pyramid with the 4 sides. Well, what if I had 2 electron pairs? Well, I know electron pairs take up the most space. The first one, it didn't matter where it went because these are all 90 degrees. The second one, it's going to go on the opposite side. So I can see all the atoms that are left are all in a plane, and that plane happens to be a square. So if you can't see these 2 atoms, it's just a square. So it's square planar. So again, you can memorize every shape, or just memorize the base shape and go from there. So 6 things, I'm going to have 1 in the s orbital, all 3 p's are being used up, and then to get up to 6, 2 d's have to be used. So the basic shape is you've got your central atom. It's got an atom attached above, below, in the plane this way, in the plane this way, and then one that comes straight out at us, one that goes right behind. So fat wedge line, dashed wedge line. Wow, that looks just like it's popping out. So then, let's draw an example. I've got phosphorus hexafluoride. I know my phosphorus has to make 6 bonds. Phosphorus only has 5 valence electrons. So I'm going to give it that extra -1 charge there. So, and this can happen because phosphorus is on the 3rd energy level, so it has access to the D's. So I'm going to go ahead and spread out 6 valence electrons. 1, 2, 3, 4, 5, 6. And that's phosphorus is 5 plus that -1, I get 1 more. There's going to be 6 fluorines. So 1, 2, 3, 4, 5, 6. And they all brought 7 valence electrons with them. This shape has 90-degree bond angles all the way around. So every single one of these, all angles are 90 degrees. Not 9, 90 degrees. Since they're all 90, and you can tell every time you flip the thing over it looks the same, it's symmetrical. So this is a nonpolar molecule if you have all the same atom attached to the central. So if we have 6 things and 5 of those things are atoms and 1 is an electron pair, it's still 6 things. There's S, P, 3, D, 2. For this guy, by the way, when I say the atoms, I'm assuming their atoms are singly bonded. So it's the same shape, right? So I've got 1, 2, 3, 4. Let's see, there. So there's 4. And then I'm going to have 1 atom coming out at me, so fat line. And then going back, I'll put the lone pair. Okay, so that is a square pyramid because we can't see the lone pair. So this guy was octahedral for the 6 atoms being attached. And this guy is going to be square pyramid. All right, so for my example for square pyramid, I've got chlorine. Chlorine has 7 valence electrons. I can see it's going to be making 5 bonds. So I'll put chlorine in the center. I'm going to spread out the 5 electrons that are for bonding. 1, 2, 3, 4, 5. And then leave the other 2 as a pair. 6, 7. Okay. So I will put 1 fluorine at each of these. And again, fluorine brings its 7 valence electrons with it. So that is my square base pyramid. This guy's no longer symmetrical because of that electron pair. The angles are going to be just slightly under 90 degrees. So a little less than 90 because that lone pair is squishing them a little bit. And since it's not symmetrical anymore, we now have a polar molecule. The negative fluorines aren't going to cancel each other out. So, a couple more. Okay, we've xenon tetrafluoride. Last one. Yay. So a xenon tetrafluoride, I'm going to have 6 things. sp3d2. 4 are going to be atoms, 2 are going to be lone pairs. So I start with that same thing. Let's go ahead and go like that. 1, 2, 3, 4 atoms. 1 lone pair coming out at us. The other one has to go away because they both need the most space that they can get. They're going to go get more space if they're away from each other because they both are very large. So this is just, it's in a plane because it's flat. Planar means flat. So this is just going to be square, whoops, square, SQU, square planar. Okay, and the square planar actually is symmetrical, and all the bond angles are going to be 90 because those lone pairs cancel each other out. So it's 90 degrees, and we said symmetrical, so it is non-polar. All right, and our example for that is going to be the xenon tetrafluoride. Xenon has 8 valence electrons. I can see 4 of the 8 need to be used for bonding, so I'm going to spread those out. 1, 2, 3, 4. And the 4 fluorines, I'll put, oops, I only put on 4 of my 8 valence electrons. Not bad. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. When you draw these, it doesn't really matter so much where you put things. When I know what the shape is, I try to make my molecule look like the shape if I can. Otherwise, just spread things out, leave unbonded electrons paired, and you are good. Because when I look at this, I don't really go, oh yeah, that's a square planar. So you have to be able to look at something and say, okay, there's 6 things. Anything with 6 is going to be octahedral. There's 2 lone pairs. I'm going to put them on opposite sides of each other, so I'll have a square-based pyramid with a lone pair above and below. Ah, it'll look like that. It really looks like that. Right? Atom, atom. There. Ah, square-based pyramid, because we can't see the electron pairs. That's it. One thing I highly suggest, on chemibear.com, there's these molecules, and they rotate around. So you go to chemibear.com, go to the molecular animations, and I want to see what octahedral looks like. So you click on it, and there it is flipping around, and I get a good view of it. I think, so really, memorize this octahedral and this trigonal bipyramidal, and you can say this is trigonal bipyramidal, 5 things attached. I know one of these guys would become a lone pair in that triangle if it had 1 lone pair, and it would look like this distorted tetrahedron. There's a little lone pair. Look at that. That's amazing. A student made this, I believe, for Paul Groves, and this is his website. Thank you, Paul. So chemibear.com, go to the molecular animations.